Okay, so let us now move on to our first derivation or first design in this topic, which is the design of disc type friction clutches. So let me rub this as well. So it will be design of disc type friction clutches. So now if you have already studied what I assigned you and also attended the previous lecture, you should know that what is a disc type friction clutch and how does it look like. So these basically are, these consist of two discs that come into contact with each other, and each of this disc is mounted on one of the elements that we want to provide connection to. So here is our first element or first part, which is mounted on a shaft. It has an inertia of I1 and it is actually rotating in a certain direction with an angular velocity of omega 1. Similarly, we have our second element or second part with an inertia of I2, and that is going to rotate also in the same direction with a velocity, angular velocity of omega 2. And in order to provide an interruptible connection between these two elements, we are going to introduce the discs at the end of both of these shafts. And these discs can actually come into contact with each other or separate away whenever we want it. So in order to achieve that, we provide an actuation force F. So this F is actually called actuation force, and this is our friction clutch. So since disc type clutch is a friction type clutch, hence these two surfaces are rough, so they have a certain mu or coefficient of friction, both of these surfaces. So this is a one view of this system. If we see it from the side, so these discs will actually be circular, right? So they will have an internal diameter and they will have an external diameter or radius. So let's see, it has an say it has an internal diameter of Ri and it has an external radius of R naught. So during the design of this disc type friction clutch, what we are interested in finding out is what would be the appropriate size of these discs, what would be the actuation force required in order to engage this clutch such that this clutch would transmit a certain amount of torque or power. So we have to find out the size of the disc and the actuation force which will be required so that it transmits a certain amount of torque which is required, which we need to be transferred between these two elements. So this is our objective in all type of designing of clutches generally. So there are two methods for this particular type of clutch, disc type clutch. There are two approaches. In order to reach our objective. The first approach is to consider the discs as flexible. And in this case, we assume that the pressure distribution across the surface of the clutch or the disc is uniform. So this is uniform pressure condition. And this is based on the assumption that the discs are a little flexible. If we consider the discs as rigid as opposed to flexible, so in that case the pressure distribution cannot be uniform throughout the surface of the clutch. However, there is another quantity which can be considered uniform in this case, which is called uniform wear condition. Right? So uniform pressure, uniform wear condition, depending upon what do we assume about the nature of the discs.